We're going to talk about the distance formula in this video, and when we're measuring distance in 2 dimensions, it takes a little bit more creativity, maybe I'll say, than if we are just measuring distance left and right or up and down in 1 dimension. We know that 1-dimensional distance is just found by subtraction. The distance between 4 and 7 is 3 units because 7 minus 4 is 3. Okay, or the distance between -1 and +1 is 2 units because 1 minus -1 is equal to 2. Okay. But maybe I'm standing here at the point 4, 1, and you are standing down here at the point -2, -2. And we want to know how far apart we're standing. Okay, we want to know that straight line distance if we got out the measuring tape to measure from here to there. Okay. When we're finding distance in 2 dimensions, we're going to break down our thoughts into 2 pieces. I'm going to cheat and use my straight lines here. Okay. One thing that we have to worry about is how far apart these points are left and right. The other thing we have to worry about is how far apart the points are up and down. And then from there, notice what we've created is a right triangle. Okay. Let's pick a different color, green. So we've created a right triangle there. And if I want to find the distance, we'll stick with purple for D. Okay. If I can find the legs of this right triangle, meaning these vertical and horizontal dotted green lines, if I can find those lengths, then we can use the idea that a squared plus b squared equals c squared. Okay. This is known as Pythagorean theorem, and what it says is the sides of the right triangle, if we let the legs be a and b, and the a and b I can interchange here, they're the 2 sides that make the right angle. Then c is the hypotenuse, or the longest side. Always, always, always will have the relationship a squared plus b squared equals c squared. So now I said earlier when I was doodling over here getting my graph ready to go that if we are wanting to find distance in 1 dimension, we can do that with subtraction. Meaning if I want to figure out how far it is between -2 and +4, then I can subtract them. 4 minus -2. And of course this is small enough and close enough together if I count on the graph, 1, 2, 3, 4, 5, 6. It really is 6 steps between those 2. Okay. If I were to subtract them in the other order, that's fine. I would just need to take the absolute value because distance, I always want to consider distance as a positive measurement. If I wanted to find the vertical distance here, up and down has to do with the y-coordinate. And so if I want to know how far it is between -2 and +1, we can subtract 1 minus -2 or -2 minus 1. And we'd get 3 or -3. Of course, we would take the absolute value if we went in that direction and say that vertical distance there is 3 units. Okay. So if I want the distance between those 2 points, we know that a squared plus b squared equals c squared, which means here's from my diagram up here, I called the horizontal side A. So we could say 6 squared plus the vertical side is 3 squared equals, instead of c squared, I'm going to call it the distance squared. Okay, but you could leave it as a c if you'd prefer. So order of operations says first I'm going to square them and then I'm going to add them together. And I know that the distance squared is 45. Now, if I want to find the distance and solve this for d, my shortest path to that is to take the square root of both sides. Now, when we were in section 1.4 in our textbook in college algebra, different section in intermediate algebra, we said if we put the square root into the problem ourselves, we have to put plus or minus there. But since in this example, distance represents something specific, meaning a measured length on my page, we don't need to worry about the negative option there. Oops, we also am not going to write a 9. If we simplify the square root of 45, a 3 gets to come out, and a 5 is stuck underneath. Okay, the distance between those 2 points is equal to 3 times the square root of 5. In general, on our page, and if you, I always start with a numerical example like this so we can see it and point at it and figure out where all the pieces come from. But if you look in your book at the distance formula, it says if you have 2 points on your page, x1, y1, and x2, y2, if I want to find the distance between those points, it's the square root, let's try that again, sort of x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared. Okay, all of that under the square root. Now, this formula is an ugly looking formula, but it is just a snapshot, that formula is, of everything that we just did right here. Okay. We found the, I'm going to go with yellow, we found the 6 here on the left by subtracting the x coordinates. Okay. Then we came back and we found the 3 by subtracting the y coordinates. Okay. Then we said a squared plus b squared equals c squared, so we squared them next. Okay, and then we added them together. And then in the last step, we took the square root. Okay. So again, the black formula, this distance formula here in front of us, is just a snapshot of everything we did. We found the horizontal distance on our triangle by subtracting the x's, the vertical distance by subtracting the y's. Then we said a squared plus b squared equals c squared. And last we took the square root. So let's say we have the 0.5, -4, and the 0.2, 3. Go ahead and pause your video here in just a moment, plug it into the distance formula, and see if, get as far as you can, and then when you turn the video back on, sorry, the answer is going to be there. Okay. So you will subtract the x's, 5 minus 2, subtract the y's, -4 minus 3. Okay, understand that if you went in the opposite order, that will work as well. 2 minus 5, or 3 minus 4. And it's fine because when we square it, whether we square 3 or -3, we're going to get positive 9. Whether we square 7 or -7, good grief. This is 3 minus -4. It will in just a moment. Say 3 minus -4. Okay, whether you're squaring 7 or -7, you're going to get 49. Okay. When you add them together, you're going to get 58. When you try to break that down, you're going to find out you can't simplify this any farther. 58 is 2 and 29. Those are both prime, and there's not enough of them to come out. So we're stuck with square root of 58. Okay.